Hey guys, Mr. Enyart here, Mr. Enyart's Mathematical Compositions. This is grade 6, module 6, lesson 2, talking about displaying and reading statistical data. Let's do it.
All right, here we are with grade 6, module 6, lesson 2, talking about data distribution. And you can pause the video and read the example, but I'm going to go over the key to making sure you can read your data, create graphs, and get information from it as easily as possible. And step 1 is to organize your numbers in a better way than just a big list like you see here. We first want to put them in order from least to greatest. And we want to make sure that we can easily see the difference between them. Now, a computer's typing, so you can see there's a space between each of these numbers, but if you're not careful, you might end up having 2 or 3 numbers close together and make it look like a 4 or 5-digit number. So we want to always either put commas between them or list them vertically, put them in little boxes to separate them. So let's start by reorganizing these numbers in some way. And it doesn't have to be the same for everyone. If you like the vertical list, if you like making tables where you do boxes, then do that. I'm going to do it a couple different ways, and then you kind of just pick and choose which way makes the most sense for you. So then you can answer questions from it and use it to make graphs or other more visually pleasing ways of displaying the data. So here's what I did. I went through, I made a box and I cut it into 22 equal pieces because I counted how many numbers there are. That's an important step, especially when you're dealing with this many and this many that are similar. Count them and have an idea of how many numbers you're dealing with. There's 22 students, it tells us that there, but I counted anyway. Then I put the numbers in order from least to greatest, and instead of crossing them out to where I wouldn't be able to see the number, I put a check mark above it. That way I can always refer back to my original data list. It's also very important to make sure you really understand what these numbers mean. It makes it a lot easier when you know what they represent. Each of these numbers, according to this question, according to this situation, is a specific heart rate for a specific student. So this 89 represents a heart rate in beats per minute for one student. That way you can always look back and remember what they're for and answer these questions more easily. If all you do is see numbers and then copy numbers and then they ask questions about it, if they start using the terms from the original situation, it may confuse you. So make sure to read carefully here and take the time to organize neatly because it makes life so much easier as you move forward. And now you answer the question. So lowest heart rate be on the farthest left, 79. Highest is 90. Heart rate greater than 86 would be the 87, 88, 88, 89, and 90. So 5 students. And the fraction of students with less than 82, we will just start with our total of 22 students. So with 22 at the bottom, I then count 81 and 79, which are the only two less than 82 beats per minute. And then I can simplify that to 1 out of 11. And the most often, again, I just count, this is our mode, right? There's 4 83s, and then there's several that have 3, but none of them that have as many as 4 occurrences. So 83 beats per minute is our most often our mode. So one other way, or one of many other ways, but a great way to display this kind of data that allows you to shrink it from size from right to left would be to make a dot plot. You can also make a line plot, which uses X's. I like the dots because it's easy using this app. But from 79 to 90 was our range, right? So there's a range of 11. And then I just put a dot for each number that was there. There was 179, 181, 282, so on and so forth. And then I count my dots and make sure I have 22. This will be useful on the next page. And so now we can answer the questions on this page. So I'm looking at the data, trying to find the center of it. There's 22 numbers, so it'd be between these two, either 84 or 85, which you could say either of those because that's about. But I could also try to find the true median, which would be what's between 84 and 85, and 84.5 or 84.5 is. Another way you can do that to find the median of an even number of data is to add up those two numbers and divide by 2, which is to find the mean of just those two, which will give you 84.5. I would consider our lower outliers 79 and 81 and our higher outliers to be 89 and 90. They're by themselves. They don't have repeated numbers as 82 does and as 88 does. So that's what I would go with there. The typical heart rate could be anything between 83 and 86. Obviously, 83 is the most common, but then you have 3 at 84, 3 at 85, 3 at 86. That seems to be the heart of the data, the most typical. The dot plot that we made on the first page, I added a dot for Mia at 80. And by looking at it here compared to all these other ones, I think it's safe to say that Mia's heart rate is low compared to the majority of the class.
So here's a fun challenge to see how you read dot plots. I have 4 dot plots, A, B, C, and D, and 4 options. Ages of 4th graders, heights of 8th grade boys, hours of TV watched at night, and languages spoken by students. Just looking at the numbers and making some reasonable guesses, pause the video and see if you can match the number to the correct dot plot. So hopefully you were able to get on and figure out which dot plot goes with which number. And I think for the purpose of this, process of elimination would be nice, but also just recognizing right away, like this one has big numbers, okay, 58 to 72. These ones are pretty low. This one only has 3 options, 1, 2, or 3. And this only has 2 options, 9 and 10. And so when I look at these, I think, oh, well, 4th graders, aren't 4th graders about 9 or 10 years old, right? So I would say the majority of them are 10, but some are still 9. I'm going to go with age of 4th graders with dot A. So boom, right? Heights of 8th grade boys, though, obviously, what is a height of 0 or 1? That wouldn't make sense. But 58, 60 inches is 5 feet tall. And if these are 8th grade boys, maybe we've got some 5 feet tall guys. I think the height of 8th grade boys is going to go to dot plot D. Hours of TV watched each night versus languages spoken by students. Looking here, is there any way a student doesn't speak a language? So this one is kind of impossible for that, right? Everyone has to speak at least one language, even if it's sign language. That's a language, right? English or Spanish. And it looks like we have a 0. We have 3 people at 0, so it can't be that 4 is dot plot B. 4 must be dot plot C, and it makes sense because the majority of us only speak one language. But some people are bilingual, right? They speak 2 languages, and some people even learn a 3rd language. But obviously, it becomes fewer and fewer. So I'm going to go languages spoken to dot plot C, and hours of TV watched to dot plot B. So yes, there are some people, unfortunately, who are watching 8 hours of TV at night. But for the most part, it's down to 2 or 1. And then we have a few up here, and then a few that don't watch any TV. So like always, pause the video, try the problem set on your own, and then check back. All right, I'm about to put the answers on here. So here we go. Okay, so here we go, and I'll zoom in so you can see question 1. Now A can be one of hundreds of questions. You can ask lots of statistical questions. I happen to go for, what's the most common vert in the NBA? That'd be a question I'd be curious, like what's typical of an NBA player? And you can tell that from this dot plot. You could ask what's the most, what's the least. You could ask lots of different questions, but that's what I went for. For B, 43 inches is the highest, 32 is the low, 38 is the most common or the mode. 10 players jumped that. I just counted the dots. Each dot represents a person, right? So understanding the dot plot's important. 3 jumped higher than 40. We have 1, 2, 3. And I would say that 33, which I added there, is lower than average, right? For number 2, it's actually pretty simple with just some logic, even if you have no idea what's going on, because if any means there can be a 0, and there is no 0 on dot plot B, so A has to be A. And days of the week, right? How many days during the week? There's only 7 days in a week. How could we have an 8 and a 10, and especially a person at 10? So that has to be, B has to go with B. And for the last questions, we're really just looking for some insight, some logical insight. So what would it look like to have a dot plot of hours of 6th graders are in school during a typical school day? Now, it did leave it vaguely open. Is this United States, Europe, Japan? Are we talking about Australia? I don't even know about over there. But I know in America, it's pretty typical to be at 7 hours, right? From 8 to 3 or 8:10 to 3:10, 8:30 to 3:30, 7:45 to 2:40. But there could be some places as little as 6, maybe some as much as 8. But I would think it would be a very tight a very tight group between like 6 and 7. You wouldn't find anything, with a 0, anything up at like 10 or 12. That's just ridiculous, right? And then for B, for video games, man, this could vary. This could be from as many as 0, right? Some kids may not have any video games, to well over 20, 30, who knows, right? But it would be a very broad number from 0 through well above the 20s, and the dots would probably be spread out, while this one, the dots would be close together.